Let's continue overview of our final exam by going back to the list of things to do. So let's review this now. So we need to construct detailed class diagram. I am giving you some hints of what I envision as a set of objects, but it's very important that we include all essential data attributes and operations in this design. So basically all operations you can identify in any of the description of the requirements. All classes should have a full set of operations and data attributes ready to be programmed in an object-oriented programming language. That's the level of detail that I am going to require you here. So of course you need to be able to finish every class and add all of the essential data attributes and operations. Documentation for our classes you will be able to find directly in the Car-Rental system questionnaire form. Okay, so here we have basically just a few questions. Design pattern related questions, state diagram at the top, and here is the description of all the classes. So just the usual format. Use the class name, one line description of the class, just one sentence description for its purpose, and then what do you consider to be this class responsible for? Right, just write the description of what you think each class is responsible for. So this is the number 2 item of things to do. Object pool. So if you think about application of an object pool, I already gave you a hint. I think that the car fleet here could be managing a fleet of cars using the object pool design. Remember that the pool object itself should be designed as a singleton. So review the singleton design pattern and make sure that you add get instance operation to this class and everything appropriate that comes with object pool management. So the next challenge is to combine object pool design with a proxy design. Well, if you consider all of the required measurements on car mileage, inspection, dates, all sorts of requirements that we've seen down there in the requirement description, I think that the car is a great candidate that it can be implemented using the proxy design pattern. So I'm not going to change this class diagram, but I'd like to illustrate what I would do to combine our object pool with the proxy design pattern. So the car should be moved aside as a class right here, right? So we can have car class put aside right here and convert this box to an interface. Just I typically name my interfaces with a capital I in front of the name of the interface. So iCar would be my choice. Then we can have a car proxy class, right? So we can have a car proxy class right here. So we can have this named car proxy, whatever, and of course the car proxy will delegate all requests to the car class, and at the same time both of these classes will implement this interface, and of course the car fleet will communicate with all the cars using this interface. So whenever any operation specified in the proxy design interface right here will be delegated to the actual car or the actual proxy. So the car proxy obviously can be used to determine whether the car needs service or inspection or any other information can be examined by the proxy to signal all sorts of garage operations. So I think that this specific car proxy class can have access to garage operations, because the car proxy will be calling methods in garage operations to say, let's create a service request for an inspection of this car, okay, or let's make sure that it gets inspected. So the car proxy can be communicating to the garage operations, and there should be corresponding operations right here. I mean, the methods available in this class to say create service requests or create inspection requests, or decommission this car, basically sell the car or something. So these are all things that could be delegated to the garage management users, and so they can process our request. So the car proxy is definitely very well would fit very well into an idea of an object pool of cars, and using both proxy and car implementing the same interface. We had this discussion before. So that's my take on the proxy design, the way it could fit into this specific challenge right here. There will be fields in the questionnaire form to explain how, basically write down what would be the benefits of using the car pool, the object pool management overall in our design. What are the benefits using it here? Just think about all the benefits that we've discussed in the past, specific to our discussion on object pool. Use class inheritance. I kind of gave away what I would envision here as class inheritance. If you really want to, you can maybe split this car class into more specific forms. I mean, you can have maybe mid-size, full-size, minivans, vans. You can have a variety of vehicles available, and perhaps they would have some specific things that may be needed to manage differently by garage operations. So there is a potential to having this car class to reorganize it into hierarchy of more specific types of vehicles rather than this generic car. Include one creational design pattern of your own. So remember, we discussed prototype, we discussed abstract factory, creational design pattern. So that would be beneficial to any kind of hierarchical structures to manufacture objects of specific concrete requests, for instance here. So abstract factory design pattern could be used for sure in the system, but you can also review other creational design patterns. If you think of something, you can add this to your design. So beyond the class diagram, we also need to construct the state diagram for the car class. So remember that it's very likely that we're going to implement car. In fact, it's a requirement to implement it as a stateful object with well-designed states. So we need to create the state diagram. So in addition to the state diagram, at the top of our of the form, we have essentially the state transitions, the description of the entire state machine. So you can say from available, right? If car is available is one of the states. The event is rented out. Right, so basically it's just being rented, so it transitions to a state rented, right? Rented, and then the car can be returned, right? And when the car is returned from the rental, so it goes from rented to, and you can basically continue continued description of the transitions of all these states. So I think as an example returned, there should be something like pending inspection, right? So it's just very very obvious that at this point it definitely needs to be inspected just upon quick inspection upon a return, and so forth. So from pending inspection, based on indicators that we discussed about these mileages and times, like time periods of 6 months and so forth, it could go into different states. For example, 3,000. So as an example here, we can say that 3,000. Or rather 30,000 mileage, so it needs to be decommissioned or to be sold. I would just say decommissioned from our fleet, but it could mean that it should be prepared for for the final inspection and tune-up and being put up for sale. So even from decommission, it could further be expanded to other state transitions. So this is an idea. Okay, so this is an idea of what you could do with think about the states that the car can be in with respect to all the services and available, not available, and so forth. So it's just basically the description of the entire state machine. And as we discussed right here, we need to be able to construct the state diagram with all the transitions and submit this as well. And finally, when the customer takes the car for a rental, I want you to construct a sequence diagram for the use case where a customer is renting a car. And of course, it will include a sequence of operation called by different objects. And so make sure that all operations that you use in sequence diagram are found somewhere in the objects, in the corresponding objects. So there should be no discrepancy between the operations that you use in your sequence diagram compared to the operations that you specify on all in all classes in your class diagram, which means that it both should be in sync, and not like you start using some operations in your sequence diagram which I am not able to find in your class diagram, and vice versa. So this is our Endterm exam overview. So just as always, be sure to save your progress as you work on the information you put into the form. Just make sure that you save changes periodically, and of course submit for grading when you're done. Thank you and good luck.